Our next piece of understanding functions will be about these things called inverses. And in your notes, this is section 1.4, starting on page 21. But before we do that, I'd like to take a look at that sheet that hopefully I gave you in class, and if not, you can find a copy in Google Classroom. Section 1.4, an introduction to inverses. I'd like you to read through the top, and I'd like you to do problem number 1. There's nothing new in problem 1. Take a moment and tell me $5 in US dollars is how much in pesos? Well, let's see. Let me just try to understand this here. F takes US dollars into pesos. G takes pesos into US dollars. So I want to convert $5 to pesos. That means I need to find F of 5. So I'm going to go do 20.41 times 5. Okay, we'll want a calculator for this. I think that is 102.05 pesos. Now what I want you to do, read part 2, see what you can do. Part 2 says take your answer from part 1, convert back to US dollars. So I want to find G of 102.05. Okay, so I'm going to plug 102.05 into the G function, which means in this case I have some multiplying to do. 102.05 times 0.049 is 5.00045. I'm going to round to 2 places, and I'm going to, so that's kind of interesting. I'm getting $5. Why do I feel like that makes perfect sense? Why I'm getting $5? Aren't F and G just sort of undoing each other? If F converts dollars to pesos, then we take that same peso amount, go back to dollars. We should have exactly what we started with. Will that work for any dollar amount? Sure, I think it will. And why? Well, the whole idea is F and G are inverses of each other. One undoes the other. And I think if you look at kind of what we were saying, F takes dollars to pesos, G takes pesos to dollars, they do the complete opposite of each other. These are the types of functions we're going to be looking at today. In your notes, our definition of inverses, we're going to say two functions are inverses if one undoes the other. Two functions are inverses if one undoes the other. Two functions are inverses if one undoes the other. Copy that down. For example, function 1 might input A and output B. If function 2 is the inverse, function 2 will input B and will output A. They do the opposite of each other. You input A, you output B. Here you input B, you output A. Have you seen these two formulas before? And if so, do you know what they are? You might have seen these in science. This is the formula that converts Fahrenheit to Celsius. This is the one that converts Celsius to Fahrenheit. And these are inverses of each other. Our ultimate goal for this lesson is to figure out, if I give you one of these, can you create the inverse function? This one would convert Fahrenheit to Celsius. Could we go through some algebra to create a function that would convert Celsius to Fahrenheit? There are two ways we're going to look at creating inverses. The first thing we're going to look at is how to take the graph of something and graph the inverse. Here's our rule. If the graph contains the point a comma b, if the graph contains a comma b, the inverse contains b comma a. If the graph includes the point a comma b, then the inverse will include the point b comma a. Copy that down. So let's see how to do this. And I'm actually going to make a little table for this first graph. You don't have to do this, but I think it might help a little bit. The original and the inverse. I see the original has the point 3 comma 1, 6 comma 2, negative 3, negative 1, negative 6, negative 2. The point is, if the original has AB, the inverse has BA. The original has 3 comma 1, which means the inverse is going to have the point 1 comma 3. The original has 6 comma 2. The inverse is going to have 2 comma 6. And negative 1, negative 3, and negative 2, negative 6. Well, go graph those points. 1 comma 3, 2 comma 6, negative 1 comma negative 3, negative 2 comma negative 6. I really just dealt with the 4 obvious points over there, but again, there are infinitely many points on the line, so there will be infinitely many points on the inverse. I'm just going to connect them. And that graph is the inverse. My original had the point 3 comma 1, my inverse has 1 comma 3. My original had 6 comma 2, my inverse has 2 comma 6, and so on. Okay. See if you can do letter B. Make a table if you want, or if you can just think about it as, okay, I have 3 comma 1, so I know I need 1 comma 3. That'll work as well. See what you can do. I think I'll make a table just so we really see what's going on, but again, this is not necessary. I've got 0 comma 2 on the original, which means I'm going to have 2 comma 0 on the inverse. I need a point over there. I've got 1 comma 3 on the original. I'm going to need 3 comma 1 on the inverse. I've got 2 comma 6 on the original. That's going to give me 6 comma 2 on the inverse. Got negative 1, 3. That'll give me 3, negative 1. I've got negative 2, 6. And that's going to give me 6, negative 2. I'll go connect those dots. And I'm going to get something that looks like that. What is a little bit interesting to notice here is the original was a function. I don't think the inverse is a function, though. Wouldn't pass that vertical line test, but that's okay. It's still the inverse. Finish copying that down. Let's go on the back. In letter C, I didn't give you any clear points. So all we're going to do is we're going to put a couple points on here. How about we put a point over here, maybe a point there, and start with those. 0 comma 1 is on the original, so what point's got to be on the inverse? 0, 1's on the original, 1, 0 is on the inverse. Okay, negative 3, negative 2 is on the original, so what's on the inverse? Negative 3, negative 2, so negative 2, negative 3. And I think I'm going to end up connecting those, so let me connect those points. I feel like I need a little bit more, though, to help me figure out how the rest of this is going to work. Well, let's see. 1, 1, 2, 1, 3, 1. I'm going to add a couple points over here. 1, 1, 2, 1, 3, 1, 4, 1. go graph the inverse of those 4 points. 1, 1 stays 1, 1. 2, 1 becomes 1, 2. 3, 1 becomes 1, 3. 4, 1 becomes 1, 4. So this horizontal line becomes a vertical line. I think we can assume as much over here. But again, take a moment, maybe put a couple more points on that ray. Reflect those and finish it off. -4, -2 becomes -2, -4. -5, -2 becomes -2, -5. -6, -2 becomes -2, -6. Yep, it is giving me another vertical line. There we go. You try letter D. Stick points on my original. This is just my y equals the absolute value of x function. If we do this, 0, 0 becomes 0, 0. 1, 1 becomes 1, 1. 2, 2 becomes 2, 2. 3, oh, this is kind of interesting. I think everything on this part of the graph is going to stay exactly where it was. Not true, though, over here. -1, 1 becomes 1, -1. -2, 2 becomes 2, -2. -3, 3 becomes 3, -3. -4, 4 becomes 4, -4. My inverse is going to end up looking like this. One other thing I want to mention regarding graphing inverses that uses some geometry ideas. Go back to letter A. I'd like to draw in the line y equals x. That slanted line with a y-intercept of 0, slope of 1. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. You draw that line in. Maybe I should have made it a dashed line. I'll do that on the next couple graphs. You should notice some interesting geometry ideas. If we draw that line in, how does the original black line compare to my inverse pinkish line? These inverses are reflections over that slanted line, y equals x. I think I actually want to add that in where we gave our rule. The inverse is a reflection over the line y equals x. Let me check that on some of the others. I'm going to do a better job, though, of making sure I do a dash line here. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on. I'm going to draw in that y equals x. Yeah, I think if I was to fold my paper over that line, that black parabola would match up with that pink parabola. Do that on the others. Connect those dots again, dashed line over there. Yeah, you fold it, this horizontal line becomes the vertical line, the slanted line becomes that slanted line, this horizontal line becomes that vertical line. And over here, well, because we had points that were right on y equals the absolute value of x, they stay there, and these get flipped over there. So that's how we can do the graph of an inverse. To create the formula for an inverse, it's actually going to sort of work in a similar way. Notice that with my graphs, all I was doing was switching the x and y coordinates. I'm going to do the same with my formulas. Number 1, I'm going to switch the x and y. I'm going to switch the x and y. So to do that in letter A, I'm going to switch my x and my y, and I'm going to get x equals 2y minus 8. Replace the y with an x, replace the x with a y. However, this is not what a formula really usually looks like. We usually need it to be solved for y. So we're just going to go through some algebra to solve for y. Make sure when you're doing this, you're showing all your algebra. What are we going to do here? I'm going to add 8 to both sides. Plus 8 plus 8. I'm going to get x plus 8 equals 2y. I need to get rid of the 2, so I'm going to divide by 2, divide by 2. There's several ways we could write this. I'm going to say y equals x plus 8 over 2. We could also just divide both of those things by 2. We could say y equals 1/2 x plus 4. That would also work. Either of those is fine. Letter B. I actually don't have a y. What can I do? Isn't y just the same as f of x? Which means my original function is just y equals 3x minus 1 over 4. So my inverse is going to be, actually, you go do that first step. Go switch the x's and the y's. Should give x equals 3y minus 1 over 4. Okay, well, we need to go through some algebra to solve for y. What should we do first? I think we need to go multiply both sides by 4. I'm going to get 4x equals 3y minus 1. Now what? I need to add 1 to both sides, plus 1 plus 1. You're then going to go and divide by 3. Divide the whole thing by 3. Y equals 4x plus 1 all over 3. Or I could separate things out and say y equals 4/3 x plus 1/3. That would also work. One more. And you know what? I don't feel like doing this one. I want to change this one to f of x equals 2x squared plus 3. Let's make it f of x equals 2x squared plus 3. Do your first step of switching the x and the y. And my original is y equals 2x squared plus 3. So my inverse is going to be x equals 2y squared plus 3. Now what? I'm going to go subtract 3 from both sides. I'm going to get x minus 3 equals 2y squared. We're going to get rid of our 2, so I'm going to go divide both sides by 2. I might as well switch the sides as well. I'm going to say y squared equals x minus 3 all over 2. But now I need to get rid of my square. How would you undo a square? If you said the square root, well, you're kind of right. Before we go on and actually finish this, little side note. If I want to solve the equation x squared equals 4, I could take the square root, and I would get x equals 2. But there's another answer. There's another number that if you square it, you get 4. What's that other number? Negative 2 would also work. So to undo a square, I'm actually not just going to take the square root. I'm going to take the positive and the negative square root, which would give me those two answers of 2 and negative 2. How does that apply over here? I'm going to say y equals the plus and minus square root of x minus 3 all over 2. Make sure the over 2 is inside your root. The plus or minus is outside. And that's how we would undo a square. And you'll see a few squares in the homework, but it's all going to work in a similar way. One more thing I should mention. Our whole goal here was to find the inverse, the function where if I plug in like 1 and get a particular answer, well, you know what? Let me stop talking in general. Let's look at this specifically. Let's take a look at letter A. You don't have to write this down, just watch. If I plug in x equals 1, I get y equals 2 times 1 minus 8. I'm going to get negative 6, which means I have 1 comma negative 6 on that original. If on this inverse you plug in x equals negative 6, you'd get y equals negative 6 plus 8 over 2, 2 over 2, 1, which means you've got negative 6 comma 1 on the inverse. That will work for all of these functions. You plug in an x and you get a y. Well, then take that y, plug it in. You plug in an x, you get a y. Take that y value, make it your x on the inverse, and plug that in. You'll get the other point out.